Now for the main topic, displacement and velocity. We'll start by defining displacement. Displacement is the distance traveled over time by an object. It is a vector. It can be positive or negative, and it can be given through the notation as t. Velocity is defined as the rate of displacement with respect to time. It is also a vector, so it can be positive or negative. It's given through the notation vt. Now, there are two types of velocity: average velocity and instantaneous velocity. So, going back on the review which I posted on my previous video, average rate of change is found just the exact same way as average velocity, y2 minus y1 over x2 minus x1. And instantaneous velocity is found through the derivation of the displacement, since it is the rate of displacement. So if you derive that to get the st, the derived form, that is equivalent to the instantaneous velocity at a certain point in time. Now if I draw a quick graph here, let's say here y equals 4, y equals 2, and x equals 5, and draw a line from here to here. Now we want to find the average velocity. All you have to do is get the y1, x1, which would be x1 is 0, 1 equals 0, y1 equals 2, then x2 equals 5, and y2 equals 4. Plug them into this equation, you get 4 minus 2 divided by 5 minus 0 should give you 2 over 5. This will be your average velocity. Instantaneous velocity, just as an instantaneous rate of change, you can find the example in the previous video on how we derived it to find the instantaneous rate of change. Now we will move on to describing graphs and how to move from displacement time graphs to velocity time graphs.